Hey everyone, this is the second of the series of our webinar that talks about
Technically the third.
The third?
Yeah.
Okay. The second, the third, we're losing track here. Of our webinar that talks about the cost of ultra-wideband. So I'm Seth Holler, CEO, Logan Maxwell.
Wearer of many hats.
And we're here again. And so as a continuation of our last podcast, we are talking about the cost, and we previously talked about kind of installation and the manual labor associated with that. Now we're talking about the hardware.
Yes.
So Logan, set the stage for us. Where, in terms of the mind of the manufacturer, what do they consider are important aspects in this process affecting both cost and time on their side?
Right. So we talked about the services, whether we're shaving time off on the survey, shaving time off on actually installing it and calibrating it, all of those sorts of things. On the hardware side, you're really going to be talking about antennas, readers, right? And then you're going to be talking about tags.
They're more than antennas, right? They have an antenna element, and then they have transceivers on their whole unit, right?
Yeah, it's a unit. Think of it, as a unit, like a little miniature cell tower almost that's going in your facility. I'm talking generally, right? Across all RTLS systems. Right. It's comprised of those.
And we call them antenna units, but other people call them transponders or readers. Transceivers or readers.
Yeah, all would fit. So ours has been purposely designed to be much simpler in that way, and that saves cost on a purely hardware perspective. So instead of these very elaborate, over-featured and over-engineered readers that go, ours are actually, I have right here, I get to use my prop.
Is that in the order of thousands of dollars this would cost?
Yeah, right. So ours is going to be really in the order of the low hundreds. Usually it's going to be in order of magnitude less than a typical reader, but of course that can vary depending on what type you're buying. So but traditionally, about 10% of what you could expect to put up. And that over the course of a site saves a lot on just the infrastructure cost, just the true CapEx cost of the system. And these readers have also been designed in mind to have an in and an out and multiple modes of power. That's an also important thing.
Well, that sounds very interesting. Yes. How does that help the manufacturer?
So it depends. If you have the ability, and a lot do, to run Ethernet easier than it is to find standard kind of 120 power up in the rafters of a facility, which isn't very common, you can use daisy-chained Ethernet. In and out, which is important because instead of having a home runs all back to your switch, you can have one chain that goes out through your facility. Usually you're just going to follow the cable tray, or you're going to follow the rafter, follow the beam, follow that U channel all the way out, and have your antennas come off of that.
Just from a point of view of education, like daisy chain versus home run, we're all talking about more or less Ethernet cable, right?
Yeah, there are different ways to wire Ethernet cable, yes.
And so when you do daisy chain, the amount of cable you're using is typically a lot less. Yeah. And the number of switches or switch jacks that you need are also substantially less.
Right. So WISER can usually do a whole facility. Again, this depends on size, anywhere between a few ports on a switch, maybe 3 or 4, to needing maybe 10 to 20 and for a very large install. And that can be distributed across the facility. A few ports on this switch, a few ports on this switch, a few ports on this switch. And since it's all daisy chain and not home run, it's less cable, but most importantly, it's less time of guys up on a bucket lift, taking all of those cables back. And at some sites, that means less time where your production is interrupted because the guy's got a bucket truck in the way of somebody trying to do something. So even though it seems like a little simple thing, just the fact that it has an in and out versus just an in makes a pretty large impact on how it can be implemented easily and cost effectively.
Okay, so we talked a little about the installation, and the last podcast we talked about, if something is slightly off.
It's a podcast now.
I don't know. Has it morphed from webinar to podcast?
Yeah.
Let's go. Again, let's the second or third one.
Let's lead in. Let's go.
So even if it's slightly off, it's still pretty robust in terms of working and being calibrated.
Right.
But on the hardware side of things, what other aspects are potential money savers or time savers for the manufacturer or group interested in doing RTLS?
So from an antenna perspective, or just total cost of ownership? Because for the tags, we have tags with our system as well, right? And so...
Okay, so we're going to jump from the antennas to the tags.
Sure.
Okay, guys, doing transformation. Let's go.
All right, so if we move from the antenna infrastructure, we've done cost savings there. We've shaved everything down. We've made it simple. We've made it be able to be plugged in and plugged out. We also have tags. Now, our system is an active system, right? A little different than a passive system, but when you have an RTLS system, you're usually going to be much more reliant on active systems in order to do that. These all have a battery. However, we have done specific engineering to make that not cumbersome and less expensive in the long run as well.
Well, do tell, Logan. Look at this, Logan.
I would love... thank you for asking.
Oh, no problem.
So our battery life, we have two different chirp rates. One is an active chirp rate, one is a resting chirp rate. And those two different chirp rates are custom configurable per the different site of what you want it to be. Usually in a large whip manufacturing context, we might leave that active chirp rate at once a second even. So once that width
is once a second a lot or a little?
In RTLS, to have something chirp once a second and have thousands and thousands of items, that's pretty rare and difficult to do. But we will leave it at that setting because even at that setting, this battery should last years. Oops. So you can run these, and we haven't necessarily replaced the problem of losing your stuff with having a guy run around and replace batteries, right? So instead of having 5 expediters running and finding whip, you've got 5 guys changing batteries. You don't want that. And so we've made it so these last a very long time. And in addition, they can open and you can change. It's just a CR2032 in there. You can just change it yourself.
No way, that's great.
It's very helpful.
So even when the battery dies, it's not that you have to toss the tag,
correct,
and buy new ones, which costs obviously more money. You can just simply change out the battery yourself and just keep on running.
Total cost of ownership is supposed to be down. You're supposed to make a return on investment on these sorts of systems, and so you want to keep these tags. You want to recycle them. Now, occasionally you're going to run over one with a forklift. These are IP67, so they are prevent dust, waterproof, tamper-proof. It's like, but eventually you're going to drop one in your chem bath. You're going to throw it in the agitator. It's going to be in grit blast or something. It's going to end, replace them then. Don't replace them because you need to change the battery. Go buy more batteries. And so that way we've architected the tags and the antennas in a way that can really lower that cost of the system overall.
I have so many more questions, but we're out of time on this podcast.
On this this arbitrary section of time.
So I'm going to ask you about scalability next. But for now, thanks everyone for your time, and we'll hop back in a minute.
Thanks.